Good morning. Hi. Hello. Hello. Good morning. Hi. Or good afternoon. Good evening. I don't know. It's a small world and lots of people. So hi to everybody. And no matter where you are in the world, I'm just glad to see you all. How you doing? Me too. Yeah, I'm excited for today's part too, buddy. I'm like, today's gonna be fun. We set the table yesterday. Hey, there's my friend Michael. How you doing, buddy? Good to see you. Yeah, we set the table yesterday. We looked at sort of what you would do if you're doing it incorrectly, right? We looked at all the things you might do. Hello, nice to see you. Good morning or afternoon or evening or whatever. We set the table yesterday, looked at all the things we might do before we had spring, right? Actually, what we just did yesterday was ideal, right? Because first of all, hi, Amit, nice to see you. Good morning, good afternoon, good evening, hello. It was ideal because we looked at all the things you might do when building out an application, and we stayed away from application servers. We stayed away from JNDI. We didn't do any of that. We just kind of did local things, public static void main, which is again a far sight better than what existed when Spring debuted. But yeah, it's clearly not great what we did yesterday. Still not great. I'm not proud. Nobody should be proud, and that's the whole point, right? Without some help, without some structure, it's very easy to build something that becomes an untenable mess. And even though we know about how to create our own proxies, and even though we know how to write code in terms of interfaces so as to support dependency injection and that little bit of indirection that polymorphism gives you, even though we did as much of that towards the end of our stream as possible, we're still missing a lot, right? We haven't even gotten into what it looks like to build a web app. I don't even want to try building that out without some help. So today we're going to see what it looks like to start doing things correctly, and we're going to look at Spring as a dependency injection framework, right? Again, setting the table for our journey to Spring Boot, our journey with Spring Boot. And so let's get to it, I guess. Just happy you're all here. As always, if there's questions, comments, feedback, whatever, I'm happy to answer them. Also, shameless plug, as always, please subscribe to this little channel of mine at Coffee Software, youtube.com at Coffee Software. Here, yesterday, I did a video called "Is This the Future of Java?" And it's all about manifold, which seems to be a thing that is kind of intriguing for a lot of people. So if you haven't tried this out, check out this video. It's almost 8 minutes. Hi, Thomas. Good to see you. Good morning. Good afternoon. Good evening. So yeah, check that out as well. I'm streaming here. This is where I prefer people to be. And I'm trying to build up this channel. Hello, Bekir. Nice to see you. Good morning. Good evening. Good afternoon. Hello. Okay, so let's see. Present. Do I have anything I need to Oh God, I have shame on my desktop here. I'm running Windows in a virtual machine. Let's see here. Okay, share screen. Okay. Yeah, there's the YouTube channel, and you can see this video I just did yesterday. It's 8 minutes. Like I said, people seem to like it, and they're learning things, and it's not a terrible channel. Come on, you can do a lot worse. Subscribe, baby, subscribe. Okay, so let's get to it. Where were we yesterday? So we had some code. I don't know where I put it though. Desktop. No. CD downloads. Probably here. CD boot 3. Yeah, that's it. Okay, so let's move this here to our desktop, and we'll continue our journey. rm boot 3.zip. CD boot 3. CD desktop boot 3. Hi, Max. Good to see you. Good morning. Good afternoon. Good evening. You know what I would love? If you wouldn't mind, dear chat, just every now and then, you don't have to, but where are you coming from? Where are you joining me from? I'm always curious as to the distribution of people around the planet. In previous streams, I've had people from everywhere, Asia and Europe and EMEA, Africa and the Middle East and of course the Americas as well. So, it's just feels like a very small world. I think I probably had one from, Australia, Turkey. Wow. I am so sorry about that nightmare that you are all going through there. The numbers are disgusting, just horrible. I'm so sorry. I've been watching the news, and it's hurts me. It hurts my heart. I hope you're okay. I hope your family's okay. Both of you. I see two of you from Turkey, so I'm grateful that you're here with me. I hope I hope you're okay. And Portugal. Hello. I love Portugal. India. I love India. Jai Hind. I love India. India is great. Every time I go to India, I get fatter, which is it's a good sign, Okay, so let's see here. Oops, I just took a screenshot, which is not what I wanted to do. I have a nice keyboard. I need to try again. I have a Keychron. Yeah, there you go. I've got a Keychron keyboard, and it's good, but I was in the middle of producing stuff, and I put it away. I didn't continue using it because it was hard for me to use. Ukraine, another place. I am so sorry, my friend. Another place where clearly more hugs and help are needed. Thank you for joining us today. Anyway, is the CERN of spring? CERN of spring, like the physics, the Large Hadron Super Collider, that kind of thing, CERN, or a concern, or I'm not sure. It's center, maybe. I think you mean maybe center. Dependency injection is the CERN of spring. Sure, I don't know. I don't know what that means. Let's see. Okay, let's take a look. Okay, I'm going to open this up. Hi, Vijay from India. Nice to meet you. Welcome. Thanks for joining us. Hi. Good morning. Good afternoon. Good evening. Let's see. Okay, so yesterday, friends, we did this mess. We made this horrible mess. Like what I have here is just a service, a customer service that can add data to the database, and I'm using the portable service abstraction, the JDBC template. I've got the row mapper, I've got that to read data. I've got the JDBC template. I've got we don't need this log anymore, I suppose. I've got the by ID method to return a record by its ID. I've got the method to return all. Pretty straightforward. Hi, Max. Nice to meet you from Brazil. I love Brazil. Viva a patria, So we have this basic customer service thing, and we did this the hard way. We created a data source manually, which is not production worthy. We need to configure a connection pool, certainly. But that's okay because we were able to use it in terms of just javax.sql.datasource, or I suppose jakarta.sql.datasource these days. I'm not even sure. Is that true? That probably is true. Abstract driver, data source, abstract data source, data source. Oh, it's still javax. Oh, interesting. Oh, that's right, because SQL is part of JDBC. It's part of the JDBC, which is part of the like JDK, the core stuff. Okay. So at least that didn't break. That's nice, right? All the other things that used javax have broken, except for the XML and the JDBC. Okay, so data source. We've got a JDBC template. I have lifecycle methods that I have to remember to call myself because nobody else is going to do it. I've got a transaction manager that we used in conjunction with the transaction template. So I configured both of those and I set up their dependencies and call their lifecycle methods. We've got the customer service object. But remember, we want our customer service to do declarative transaction demarcation. So I created a very sort of rough proxy here. We started with JDK invocation handlers, but then I said I don't want to have an unnecessary extra interface just to be able to call methods, right? Just to be able to create a proxy, because the interface adds nothing in this case, right? The interface is just for the purposes of creating a proxy. So instead of doing that, I'm using cglib. I'm creating a proxy factory. I'm using the proxy factory bean to create a subclass. And we actually looked at that. We even wrote some code to manually do that, overriding, calling transaction template.execute and then calling super inside of that execute template method. We looked at what that looked like manually, right? We could create our own transactional customer service class and subclasses customer service and then just call super. And then we looked at this proxy approach, which same basic approach. Whenever somebody calls a method, this method gets invoked, and we we use a transaction template to do some work in the context of the transaction template, which means, center. Yeah, Max, thank you. Yes, it's the center of Spring. Yes, but I should say dependency injection is the center of Spring, but you don't need to use Spring to do it, and that's what I've been trying to demonstrate here so far, right? We've got a data source. We've got a database template. We've got a data source transaction manager. We've got a transaction template. We've got a transactional customer service, right? This, if you cast this is still just a default customer service, right? That's what you're getting back here. And then I've added some data to the database, and then we called all the records. You know how I can apply a source set configuration from my library, build that Gradle to my application? Try convention, like a convention like a convention. I don't know, what are they called? Convention files. It seems like you can do everything in those. I look at the code for the auto config that we built over the last week for the Spring Batch. It's on Josh Long, and it's called Josh Long, github.com, Josh Long Batch Spring Boot Starter. And then if you look at the convention file, you could probably do it in there. I don't know. Sorry, I only understood every other word of your question, my friend. I'm sorry. Hey, if somebody in the chat who's smarter than I am, which is a low bar, knows the answer to this question, hey, join us on YouTube and talk to my friend Thomas here. Okay, actually, I'll leave the question there for a minute so people can read it and ingest. Okay, good. So this is all public static void main, and I made a mess. I did all this like manual stuff. Well, so why do we need transaction manager and transaction template? Well, transaction manager, we looked at that. So Spring has three big things, right? We have portable service abstractions, we have dependency injection, we have aspect-oriented programming. And the transaction template will automatically create a transaction using an implementation of platform transaction manager, of which there are many. We talked about how yesterday there are implementations for Neo4j, for MongoDB, for JMS, JTA, JDBC, Hibernate, JPA, different. Even the JTA one has a few specializations around the particular behavior of WebSphere and WebLogic and whatever the specific oddities of those. And so what we're doing is, since we don't have Spring, we want to make sure that our default customer service, whenever we do something that should be within a transaction, for example, writing data and then reading data. Right here, I'm going to write some data to the database. I'm going to do an upsert, and then I'm going to read the data. But I want this to be consistent. I want it to either all succeed or all fail. I don't want like dirty reads and writes. Okay. So in order to make that true, I could actually add transaction logic to every single method. I could call transaction template.execute, and then put everything inside of this in a lambda that goes inside of the .execute call, and that would start a transaction using the platform transaction manager implementation that we have specified here. This is a JDBC data source transaction manager. I could do that, but that would be a violation of separation of concerns. Every single method would have logic associated with transaction demarcation, which I don't really care about. I want it to just be like set and forget for most of the cases, and I want it to be overridable for everything else, right? So then we created a proxy, and this proxy up here, like I said, this proxy is a subclass of default. It creates a dynamic subclass of default customer service. But whenever somebody calls a method on that subclass, we get an event listener kind of. We get a callback, and that's this right here. And in that callback, we get a pointer to the invocation. Can I delete this? No. We get a callback to the invocation, and there we're able to say, okay, what method got called? Great. There's the Java lang reflect method. What arguments do we have? And I believe that's just an object array. And then we're able to say, okay, within the transaction template, right, like this, within the transaction template, we're able to call the method on the delegate, on the original object that's ours, passing in the arguments, but we call that method, we forward the method invocation to the delegate, but only after we've started a transaction and then closed a transaction at the end of the method invocation, right? This is classic, AOP kind of stuff. What we're doing is we're writing code in such a way that the cross-cutting concern, the logic that all things will have around transaction demarcation, lives somewhere else. We don't want it to be muddying up our business logic, okay? And our business logic is just the logic of, working with customer data. Very, very trivial example, but hopefully indicative or illustrative, okay? This is kind of a hot mess too. We had to use the JDBC template to create a statement, and we wanted to return generated keys, and then we set a parameter for the name that we're going to be inserting, which is that one there. And then we use the key holder, the generated key holder, to access the generated ID of the JDBC statement and get a number out of that. This should be a number, right? And that should be var, because the world is not that ugly. And then we get the ID, and then we turn it into an int, and we then search for the same customer that we just wrote by its ID. Okay, so we're turning it right back around, and we're doing that query for object given the ID that was just inserted. So when you call add, it writes the data, and then it finds the record that was just written and returns it back as a customer object, okay, fresh from the database. So that proves that it works. Okay, so yeah, today goes beyond that. Good vibes, yes. So the first concern of Spring, Max, my friend here says, is to provide a great IOC engine for Java ecosystem. I hope so. Yes, that's definitely part of it. Well, actually, there's three concerns. Like I said, there's three. This IOC and dependency injection are often mentioned in the same breath. They're not the same exact thing, but close enough. Hi, Ahmed. Good to see you again. Yeah, it totally does go beyond that, right? Good vibes all around. So okay, so we looked at portable service abstractions like the transaction template and the JDBC template. We looked at dependency injection and how we have our wiring up. The logic that is associated with wiring up our application all happens here. So this code is not written in such a way that it cares about how to create this JDBC template. Remember, in our first few revisions of the code, we had a customer service where I was manually creating a data source in the customer service. And then I was doing all the data logic. I was doing all the JDBC logic using low-level data sources, right? So we've gotten a lot better now. We're using JDBC template, which is higher level, and we don't care how it gets created. We've extricated that logic here. We had to do some weird stuff around life cycles. So we have all this manual lifecycle management. That's, it's better than what we had before, but it's still kind of ugly. We had to create a proxy manually, which is kind of ugly, just to get like set and forget default behavior for transaction demarcation. All this to say, we can and should do better. So let's today take a look at Spring, okay? So what we're gonna do, let me make sure we've committed our atrocities to repository here. Git commit atrocities committed. Okay, git push. We're on a fresh build here, okay? What we're gonna do today is see if we can make this a little bit cleaner. So what we've got is we're gonna use Spring. And what we're gonna do with Spring is we're gonna create a Java configuration class, okay? So class, data configuration. Pretty trivial stuff here. We're gonna create a configuration class. And the reason we have this is what we wanna do is we wanna have the same wiring that you see here, the same mesh, the same build of our objects. We want to do that here. And we're going to extract that out into separate bean provider methods using Spring, okay? And hi, Ahmed, good to see you again. And the reason we're going to do that is because Spring can help us. If it knows about the objects in our application and how they get wired together, it can do things for us much more readily, much more cleanly than we could do ourselves. So let's take advantage of that, okay? The first thing we're going to do is build up our data source, okay? So we're going to build a data source object here like this. So we'll say our data source, blah, 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 return data source. Now, and technically, if you know the subtype, you should expose the subtype, right? So we're going to tell Spring, hey, we've got a bean of type driver manager data source, okay? Now this is ugly. I've got these hard-coded string values in here. We'll see how we can fix that in a bit. I'm going to build up a bean of type JDBC template. Okay. So we'll say JDBC template. Good. Turn that template. And in order for this to work, in order for this JDBC template to do its job, I need a bean. I need a dependency of type data source. And this is a data source, right? It's a driver manager data source, but it's also just a regular JavaX data source. So I'm going to expose the most specific type possible, but I'm going to consume the least specific type possible, right? So provider, consumer, you want to give Spring as much information about the bean as possible, all the interfaces, all the, the parent hierarchy types and all that stuff. Okay. But the JDBC template only needs a data source, a javix.sql.data source. So just ask for a data source, nothing more specific. I could do that. I could say I want that, but I don't need that. So why ask for it, right? This might change tomorrow, and you don't want this code to break just because you changed the particular subtype that you're returning from here. Okay, so good. So we got that. What about this? I need a data source transaction manager. Again, this is a platform transaction manager. It's an implementation of our platform transaction manager hierarchy. Okay. So again, paste that, return PTM. And this is going to be a specific subtype. So instead of returning the base type, I'm going to return that. And, maybe even, there you go. Let's just be very specific about it. Same thing here. I need a pointer to a data source to do my work. So I'll just inject that as a collaborating object. What else? I need a transaction template. Okay. And so transaction template. Right. TT. And this needs a pointer to the platform transaction manager. So we'll just inject that. PTM. All right, good. And what else? Up here, we need this customer service object, and that needs a couple of dependencies, doesn't it? So let's go down here. We'll say bean default customer service. Okay. And we are going to return this transactional customer service. And we're gonna come back to like how to make this work without doing this manual proxy, but let's do that in a minute. All right, there's this. So this requires a pointer to the transaction template, and it requires a pointer to the JDBC template. So transaction template. Okay. So there's our two beans, our transactional customer service. Still got this icky like proxy that we had to create ourselves, but at least we're cleaning up their logic here. So now I want Spring. Let's comment this out for a second. I want Spring to take control of this wiring, okay, for us. So the old way, the way we would have done this before Spring Boot, is to create a bean of type application context, and there are many specific types, and I'm going to use an annotation config application context. And it is going to do a bunch of things for us conveniently, right? One is if I pass in a configuration class, data configuration class, it'll automatically wire up everything in that config class, okay? Another way I could do this is if I just say no args, but then I do application context register, and I do that, that'll also work. Then I'm going to say start, okay? I don't know if I need to do that. I think I do need to do it. If I do register without anything in the constructor, I think I need to call start. But let's see what the result of that is, okay? The result is I have an application context. I can use the context to get access to our customer service. I can say, give me a pointer to the bean default customer service class, okay? Let's try this again. And all the existing logic should continue to work unless I made a mistake, which is entirely possible. It's, hi, yes, my friend, this is all the live streams are on my YouTube channel, youtube.com, at Coffee Software. So at COFFEE software, one word, lowercase, etc. And so, yeah, you can watch them all there, everything we've done for the last, there's now, gosh, if each live stream's like an hour or more, there's probably 20 hours or whatever of content there now. So, okay, good. So let's run this and see what we get. We get sadness because something is broken and we don't know why. Lifecycle call refresh before invoking. Oh, okay, right, fair. Forgot to call refresh. So we have to refresh the context and say, okay, go ahead and set yourself up. I don't know if I need to start anymore though. Well, I guess I do. It doesn't matter. It looks like. But there you go. There's our results, right? We wrote those records to the database. We got them back. You can see everything is basically the same, right? We got all the terrible logging, very verbose logging, all the debug, everything is there. But all of our beans seem to be working in the way that we expect them to work, okay? Not bad. It's not much, but it's not bad either, okay? Now, let's see what we can do to clean things up a little bit here, okay? First of all, like this data source, this customer service, it is well, first of all, I can just call it customer service, I think, at this point. I'm happy with that because I don't think I'm going to need an interface. We only did that so that we have the ability to create a little bit of indirection with an interface, but there's only one implementation, so we'll keep it like this. And this transactional customer service, it's returning just a regular customer service, which feels good. It's creating a dynamic subclass of that using proxy factory main, but again, pretty simple to understand. I don't like having to add, like this customer service it's not really a complicated thing. Well, actually, a lot of these objects, they have lifecycle methods that we don't really need to worry about anymore, right? So remember, this after properties set method, like if I have other things that need to be done after the constructor, I've been saying use the constructor, right? Use the constructor to read all the data and to set up the state of the object so that it's in a valid state. But you can also have things that you want to do after all the constructor and setter methods have been invoked. And we have no setter methods here. But if you want to do that, there are lifecycle interfaces in Spring like this. So initializing bean. And this initializing bean is what provides the after property set. Okay, that's a lifecycle method that Spring will honor if it detects it on your code. So all those different beans that you see me calling after property set, that's just me doing the lifecycle management that Spring will already do. So I don't need this here, don't need it there, don't need it here. And now these become just inlineable things. Okay. Cleaner, right? It's now just down to one line for that kind of stuff. Now that I've taken care of lifecycle, you can still run the code, of course. It's I don't even know. We should just get rid of that for now. It doesn't do anything. Close this, close that, and that, and then run this. What do we get? Okay. Okay. So, wow, deprecated Gradle features were used in this build, making it incompatible with Gradle 8. I don't know how that's possible. Like, that's what bothers me, is as far as I know, this is all, first of all, it's only like 33 lines. Second of all, it seems like it's all the latest and greatest. I don't know what the alternative is. I'm using the new syntax for plugins because there's like 100. Dependencies seem to be, I don't know if there's any changes there. JUnit platform why is that? I don't know, whatever. Is it something that I'm using on the class path that's transitively like doing it the wrong way and now I'm getting blamed? I don't like hearing this. This makes me sad because it's already broken and I didn't even do anything as far as I know. Anyway, moving on. So we've got our service, got our data source, our transaction manager. We've simplified lifecycle. That said, let's look at our customer service again. I feel like we can make things a little bit easier. I'm using this bean provider method to manually create that bean, right? That object. The important thing to understand here is that Spring doesn't care how you tell it about your objects. It just doesn't care. It's completely agnostic to that, right? And to see that in action, if you want to believe me, if you don't believe me, just try creating one of the lifecycle methods that deal with bean definitions, right? And so there is a lifecycle. There's a whole hierarchy of objects called bean factory post processors. Okay, and these post processors give you something called, if you implement this interface, they give you access to this configurable listable bean factory. There's even a subclass of that called initializing bean definition registry post processor, right? So if we implement that static class my bean definition registry post processor implements bean definition registry post processor. All right, so I'm going to implement this interface, and what I'm given a callback to bean factory post processor. That's this method right here, and I have nothing I want to do here, so I could just do that. What I want to do is I want to use this. I want to use the bean definition registry, and the reason I want to use the registry is so I can register bean definitions. Okay. So let's say I want to create a new bean of type customer service. So I'm going to use the bean definition builder, and I'll create a generic bean definition. And I'll say that I have a what is a class? How do I set the class here? Set factory bean. Well, I guess is there a method here that takes yeah, there you go. That's the class is going to be the customer service class. Okay. and I want to do add constructor argument reference. And the reference that I'm going to use is to, what do I have? I've got transaction template. That's this bean right here, right? So I'm going to say add constructor arg reference, right? Bean name, add constructor arg reference. And what's the other type that I'm using here for the customer service? Is the JDBC template. It's this bean right here, right? And then I want to just get the bean definition. That's it. That should be enough. Okay. So here I'm going to register this as a bean that Spring will see, but it gets involved much earlier in the life cycle. So I'm going to use static, right? And now I'm going to comment out the one that we registered here. You can see I'm mucking with the primordial soup of the application context. I'm using something called a bean definition registry to programmatically register a bean with the context. And I'm manually setting up its arguments versus constructor and all that stuff. This bean definition that you see right here, that's what Spring cares about. At the end of the day, whether you read configuration from these configuration methods or from the archaic old XML format or from anything else, at the end of the day, they just all end up as bean definitions. So this should still work. Let's try it out. Or not. Simple. Okay, to avoid type parameters. So, AutoWire constructor cannot resolve matching constructor on class. So, did I make a mistake? What's the? Oh, customer service takes a JDBC template. Right. Okay. Okay, I forgot. It's just one type. So I forgot. I'm not doing the proxy part. So we just need to comment that out. Let's see if that works. Okay, that works. But now I don't have my transaction demarcation. But you get the idea, right? If I wanted to create a bean definition that invoked that method that creates the proxy, I could do that as well. Registering beans through these bean definitions, that's what Spring ultimately cares about, right? Is I have these bean definitions in the context, right? Your code is just a bunch of bean definitions. And so if you think about it, like, why does it doesn't care, right? It doesn't care. Maybe template bean definition. It doesn't care where you get those bean definitions. And so that's why once it's inside of Spring's application context, it can see everything. Everything can see each other. They can interact with each other. They can inject one reference to another, etc. It's all one component model. Everything is in a flat sort of space for the most part. You can do hierarchical dependency injection, but don't worry about that. Okay, so let's comment this out and let's restore our bean method so you can kind of see what's happening here. Okay. There. So we've manually done that. Now, this is one way to discover beans, is to have a configuration class with bean methods that returns a bean that you care to manage, that you want to have Spring manage. And you can declare dependencies and other things that need to be injected. If you're in the same configuration class, then you can actually do something like, you can actually make it a little bit cleaner. You can do it another way by using the transaction template and then invoking that method. For example, I can invoke the method for the transaction template. And that'll give me the same thing. And Spring has this concept of lifecycle, right? So here, I'm injecting a transaction template. Where's a bean that doesn't require here's my data source, okay? This is expensive. Every time this method gets invoked, it calls the database and it creates a new socket connection and everything. I've got Postgres running in my local machine. At least I think, yeah, I must, right? It wrote the database. I don't want to create multiple connections though. That would be very wasteful. And so here, where's my JDBC template? Where's my JDBC template? Down there. Here, I'm going to, instead of injecting it as a parameter, I'll call this data source like that, and I'll inject it. Well, okay, that's fine. It's going to create it once, and we're going to log the, let me create a logger here using Lombok, my old friend. Okay. I'll use that logger, and I'm just going to log out ds.toString. That'll log out the memory, I hope. Hopefully there's not a useful toString in here. Okay, so what do we got? I'm looking for a big, ugly toString in there somewhere. Loaded driver, create shared instance. This looks like it. Is this it? Yeah, there you go. So it's 732. There's the memory reference. Okay. Now what happens if I create it again? Like let's say I do for var I equals 0, I is less than 10, I plus plus. Okay. And I want to say ds equals this data source. And I'll log it out each time. Log.info ds.toString. Okay, restart. The code ran just fine. It ran just as fast. But if I go up here, do I see my data source? There it is. Look at that. I logged. I should have 11 logs here. I think I do. I don't know. But basically, each one has the same memory, the same reference to the same type. And that's because even though we're calling this method, Spring is inserting itself. It's actually created a subclass, and that you're calling a method on a subclass, and that subclass memorizes, it remembers that you've already created this bean, and it returns that same instance over and over. That's because beans by default in Spring are singleton. That is to say, there's only one of them per JVM. Okay, so even though I'm calling the method, Spring honors that lifecycle method. But I could change that. I could say, okay, this is going to be, scope prototype. Okay. Now what happens? Oh dear. This is very expensive and painful for my database. Okay. Let's see here. Oh, I got rid of the oops. Let me go back up here for a second. Now we'll make this scope prototype. Restart. Good. Okay. See that? The memory is different for each one. That means I've created 10 new data sources, creating 10 new connections. Very wasteful. I want to share that data source across all my code. I don't want to have different ones for each user. So I don't want this to be scope prototype. But the point is you can manage how many instances Spring creates by using scopes. Scopes can tell you if you have a single instance of the object per Spring application context, or if you have one for every new HTTP request, or one for a new HTTP session, or one for every new servlet, or one for every single use every time somebody injects it, right? That's a prototype. So there's lots of different scopes, and they control your life cycle. Okay, that's why it's okay to call the method or to declare it as a dependency in the parameter, right? I prefer to do the parameter most of the time. Okay. Okay, good. Now, what else can we do to make this a little bit cleaner? Well, I want this customer service I don't want to have to manually wire this up. Like this stuff, I get the transaction template, data source, JDBC template, the driver data source itself. All that stuff is infrastructure, and it's something I don't mind explicitly wiring up. But for my own business logic, I intend to have lots of different services, and I don't want to have to register a new instance of it each time. Okay. So what I want to do is instead, I'm going to comment that out, and then I'm going to have Spring discover this automatically. And the way you can do that is by using a stereotype annotation. It's a marker annotation that tells Spring if something is available. The root of all those annotations is @component. But there are other annotations that are also annotated with @component that have they imply extra capabilities, and they are still components. So if they are discovered, then your code will be discovered as well. If you can create your own annotation called whatever, chat bean or something, and then it would be discovered as long as @chat bean also had @component on it. Okay, so you can create your own documentational annotations here. So I've got this annotation. Spring's not going to discover this by default, right? It won't work by default. You have to actually enable this behavior. So let's see what happens. I've got this code. In my code, I've got the customer service, and I'm adding some records and all that. That should fail right now. Exactly. Okay. And the reason it's failing is because we don't know we don't know where the bean is. There's no bean. It doesn't discover it yet. In order for that to work, you have to enable component scanning. So I'm going to take my configuration class, and I'll say @component scan. And what that's going to do is it's going to look in the current package and find everything that matches this package and beneath it, and it'll automatically register it if it discovers that annotation. And you can see when I did that, now it's working. Okay. However, we have a problem. Like, so the constructor arguments here, JDBC template, it looked at the constructor, Spring looked at this, it says, okay, this is a bean, I'm gonna manage it. It's got a constructor. The constructor takes a pointer to the JDBC template. It says, okay, great, I'll provide the bean that gets created here. But we still don't have our, we lost our transaction demarcation, didn't we? We did all that work to create this proxy around transactions, but now it's no longer being discovered. And so here, we're gonna learn about another lifecycle method, lifecycle interface in Spring called the bean post processor, okay? Same idea as the bean factory post processor, but instead of dealing with the low level, primordial soup of your application context, the bean definition, instead, we're going to learn to work with objects, just before they've been created and are ready to start doing actual work. And we're going to learn something called the bean post processor. Okay, so my bean post processor implements bean post processor. Okay, and maybe I should be a little bit more descriptive. I'm going to call this transaction bean post processor. Okay. Hi, owner. Nice to talk to you. Hello. Good morning, good evening, good afternoon. Thank you for joining us. I appreciate that. So this is a bean post processor. And you register it just like before. Static, this, and this, okay? So you register a bean post processor with a static method. And you have two different methods here. You have post process before initialization and post process after initialization, okay? Hello, Chamba. That's a cool name. I don't know. I'm sorry if I mispronounced it, friend. Chamba? I don't know. It's very nice. I'm sorry that I'm an idiot. Yeah, so here's our bean post processor. And this post processor there's two callbacks. Remember we talked about the lifecycle method, the after properties set? Well, after you've called the constructor and before you've called after properties set. So after the constructor and after all the setters, but before after property set, then you get this callback here. So this gives you a callback for every single object in the Spring application context before after property set, okay? So this is a good chance to do any kind of work before any final cleanup is done, okay? What we care about, however, is this one. We want access, in this case, to a fully configured object. And what we're gonna do is we're going to look for any bean that's of type customer service. Okay, so we're going to say if bean instance of customer service CS, then we're going to return the bean with a transactional proxy, right? Just like we did before. So we'll do that here manually. Okay, return this. But of course, in order to create that proxy, so we've got the bean here, right? We've got the customer service as a bean. We're going to provide that bean, CS right there, but we still need a pointer to the transaction template. And that's a good point. I think I can just inject it, but I don't know. That should be fine, right? Let's just try it out. Transaction template. I never know because there's a lifecycle issue here, right? Will that work? Probably not. And before construct, yeah. This method gets called after post construct, but after property set and post construct are basically the same thing for the purposes of the other method, the post process before initialization. Now, my question, my friends, is, will this work correctly, or will I have the ability to get access to an application context? I don't know. Let's find out. So let me see if I can just do bean factory. Oh, let's see if I inject that instead. Bean factory. This might be a problem. Okay. Now we can say bf.get bean, get bean by a type, and we want it to be called. Good point. We'll get to that in a second, right? We haven't even gotten to the other projects. We're looking at Core Spring here. Nice question. Very good question. We're just looking at Core Spring. We haven't even looked at like Spring Data JDBC or even AOP yet, right? We're just sort of looking at how we could implement some of that stuff ourselves. Yeah, so when you use Spring Data JDBC to do at transactional and that kind of stuff, it's using transaction template, right? Behind the scenes. It's been doing that for decades. So transaction template is just a lower level, but you can totally use it. It's been in Spring since 1.0 basically for decades. Okay. Well, the question is, why are we using the transaction template if we have Spring Data JDBC? And the answer is, we're going to get there. We're doing the low-level stuff first. We're moving up the abstraction stack until we get to a place where we can remove as much code as possible. And the goal is to arrive at Spring Boot, and then once we're in Spring Boot land, to arrive and go all the way further, right? To go to a place where it's just the code is writing itself for us, basically. Okay, now, friends, we want to get a bean of a certain type. And so the type that we need here is a transaction template. So let's say transaction template.class. Let's see if this works. I don't know if it'll work. Maybe it'll work. Possibly. Bean factory. Yeah. Please work. That worked. I don't feel great about that, but it did work. Okay. So good. So we've got it like working here. And this transactional bean post processor, let's actually put our breakpoint in there. Okay. So we're going to say, okay, for all the beans in the application context in the bean factory, test the bean. Let's just log out, hey, log.info post-processing with bean name, bean named, okay? I'm going to say bean name and then bean.toString. This is you shouldn't normally need to do toString, but it does help. So post-processing. There you go. So you can see post-processing bean name JDBC template, post-processing bean name customer service, post-processing blah, blah, blah. I'm able to interact with all the different objects in the application context in the bean factory, which is inside of the application context. And it's the container of all of our beans, okay? So by having this callback method, I'm able to insert myself, in the work of creating the beans. And here I can replace this bean that's in the Spring context is called customer service. But the bean that will be there in the production code, once it actually starts up, will be our transactional customer service, right? The one that we used here that actually uses a proxy to do the work for transaction demarcation. So we're doing a little switch, right? We've got code here that's infrastructure code. This is glue code. It's bean post-processor code, right? This code lives in the Spring context, and we're able to change what people are using and what they get. So when I go to this point, where's my main method? Main method, come back. It's up here, I guess. When I ask for a customer service, what I'm getting is it's no longer the customer service. What I'm getting is a subclass. Yeah, here, you missed it earlier. We actually talked about how Spring works with bean definitions. And so that's what I'm doing here. I'm loading only the beans that I want. This is using regular Spring, there's no Spring Boot yet, okay? So here I'm creating a annotation config application context, and I'm passing in this one config class, and it's only loading these beans, the bean methods here, @bean, @driver managed data source, JDBC template, etc. And you can see post-processing how many times is post-processing here? It appears 6 times. The word post-processing appears 6 times, which means that there are only 6 beans in the entire application context, and they're only the beans that I created, okay? So this is using low-level Spring, low-level application contexts, low-level bean factories, etc. There's no Spring Boot at all. So annotation config, application context. We're getting a pointer to the customer service, but again, because we're returning a proxy, it's actually a subtype of that. So cs.class equals this cs.getClass.getName. Let's log out what the class type is. cs.class equals, you can see it's not my customer service. It's a customer service $$ Spring cglib proxy $$0, right? And that's the proxy factory bean that we're using. We're creating a dynamic subclass live on the spot. And so the code doesn't change. Our test, our little bit of example code here, nothing breaks. Everything still works, but behind the scenes, we're doing a little switcheroo. We're taking the old customer service. Yeah, the code here is a great question. As always, it'll be on the GitHub repository, and I'm trying to, let's see, the code is right here, repositories. Let's code Spring Boot 3. So I just updated it 31 minutes ago. I'm trying to periodically commit what we've done here to the repository. Okay, Good. So it's there. Let's code Spring Boot 3, Coffee Software Show. Okay. And I think I should put, oh yeah, I should totally put a GitHub link in the banner for this live stream. Good. Okay, so good. So we've got, we used this bit of glue code to insert ourselves between the production of the bean and the consumption of the bean. This happens after we have defined the bean. Hi, Shiva. Good to see you. Good afternoon. Good morning. Good evening. We've got this bean post-processor, which will take the configured bean that Spring is already fully managed almost. And yeah, I mean, Ahmed, that's a good idea, but I don't know. I think it's already too late, you know. Maybe I should have done that. It's a lot of work. Yeah, I would love some help if somebody wants to do it. You know, if they want to like submit branches or whatever. I just don't know. Let's just figure this out. Okay, so what do we have here? What do we have? We have our oh, if you can do it, please send like, I'd be glad to have contributors that want to restructure it and create branches accordingly. Please, you know. Okay, where were we, my friends? Thank you, Amit, by the way. I appreciate that. Yeah. So we've got the bean post processor. We've introduced transaction demarcation as a separate concern, right? In fact, our consumption code, the logic that's using the bean, it has no idea that we're declaratively adding this transaction behavior using this bean post processor. We're meta programming, if you will, the application context. Okay, so very convenient. We looked at bean definition registry post processors, right, for like low level bean definition creation, and we looked at how you could programmatically register the JDBC, you know, the customer service bean definition. We also looked at how you can take the customer service bean and swap it out, replace it with another subclass of that same type, and everything is fine that way. But what else can we do to make this code a little bit cleaner? Well, one thing I might want to do is enable declarative transaction demarcation, right? By doing this work myself, you know, it works, but it's very specific. I'm saying, okay, if the bean is of type customer service, then do the work. I could also look for an annotation. I could say, okay, hey, if bean.getClass.get annotations, and I could say, okay, give me an annotation of a certain type. If that's present, then do this, right? But this seems like a lot of work. It seems like I'm doing a lot of infrastructure code that I don't want to do. So instead, we can actually have Spring do this for us, right? I've been doing it the hard way to make a point. But we don't really need to do this ourselves at all, do we? We can use declarative transaction demarcation. So I say @enable transaction management, right? And this is going to expect a bean in the application context. And by the way, this proxy is no longer needed. Okay, it's going to expect a bean in the application context of type data source, of type transaction manager, etc. Okay, so I've got and if we want to configure the specifics, we can say implements transaction management configurer, but we don't need to, right? It should just look by type. So let's just see if that works by default. It should. It's been like a decade since I've done this. Hey, Thomas, good luck. I'm so excited to hear that. You submitted your talk for Spring I/O. Everybody wish him luck. He's, you know, you can do this, bud. I believe in you. Okay, good stuff. All right, so let's see now if that does the job. And same thing, we're going to print out what cs.class is. So remember, if it works, then we should automatically get transaction demarcation based on the presence of an annotation, which is @transactional. Okay, so let's restart that. Now, what is cs.class here? Yep, same thing, but we got rid of my custom proxy. Now Spring is creating a proxy, right? And Spring is doing the work for me because I had this @transactional. What do we get if we remove that, I wonder? Let's see. Right? If I remove that, there's no proxy. It's just using our bean directly, the customer service. It's only when we ask for extra help to do transaction demarcation that we get this proxy automatically created for us. And that means that we don't need to write our own proxy. We can just throw away all this stuff that we wrote by ourselves. So now we're using portable service abstractions, but all that stuff around like the transaction template and all that, the separation of concern has been removed to the background. We're using infrastructure code, but we don't even have to write our own infrastructure code. That's wonderful. We're just using regular Spring Bean, logic, and it's just doing the right thing for us. Okay, so we've got that add transactional on the bean. What else do we got? What else do we have here, friends? Well, what else can we make cleaner? One thing that's particularly offensive is I've got these strings, like in the bean provider method here. I've got these hard-coded strings in my Java code. Yeah, right? I don't like that at all. So what I want is to set up a property source so that I can read the configuration values from a file, for example, okay? So let's suppose I go here, source main resources, and I create a new file, and I've got a file here already called application.properties. Let's just say I put that there already. So I'm going to put this here. I'm going to use a property here called SQL.dataSource. Sorry, JDBC. Is it SQL.dataSource? DataSource URL, yeah. Data source. There you go. I'm going to use this property. I don't know where it came from. I'm just making this up, right? We've never seen this before, right? Spring.datasource.url. I'm going to store this here. Spring.datasource. Say password, why not? Who would have thought? Postgres. And username, Postgres. Okay. So I want that there. So I'm going to use that instead. So in order to make that work, I need to create a property source that reads in this property file. Okay. And so I'll create a property source here. Say at property source. And the property source will be a, where do I get the property source from? Property source value? Let's see. It's been a while since I've had to do this the old-fashioned way. Property source, Spring, file. Okay. Oh, look at that. They're doing the same thing we are. So db.properties. How do I read that in? Annotation config, scan, bean, get metadata. No, I don't care about that. Where's my multiple files? There you go. Oh, you can, yeah, so class path file name. Okay, good. That does work. So class path, that's what I thought, but I wasn't sure. Class path, application.properties, okay? And now I'm going to read that property source in, and I'm going to inject that property, those property values, by using the low-level Spring environment. Okay? So the environment has, it's like a dictionary. I can say, hey, give me a property of type. And what do we call these properties? We said the first one is called Spring datasource.url. Okay, so let's just take that. Wow. Spring datasource URL right here. Good. Spring, and we're going to say environment.getProperty spring.datasource.username. All right. And I'll say environment.getProperty spring.datasource.password. Okay, so this is much better. You don't want Indonesia. Ahmed, nice to meet you, buddy. Well, welcome. Good evening to you. So we've got this property, spring.datasource.password, spring.datasource username and URL. And I'm injecting that through this environment abstraction, and everything seems to still work. So we've moved the code outside from here, and we're getting the values and we're reading it in the application context. And the benefit of this is that we can change this property file before we deploy it. We can actually have another property file that gets loaded from the file system, right? And the way this property source mechanism works is we have this thing called a environment post processor, and we have property source objects, right? So you can actually override the default property sources that Spring reads. How would I do that? I think I just create a bean. So static class my property source, implement property source, right? Property source of type this one, and property source of string. Okay. There you go. And so this gets plugged into the pipeline, or extends, I guess. What is it? What's the issue? What is this issue here? Abstract. Okay. What's the oh, we have to override the constructor, I think. Yeah. There you go. So this Beautiful. Okay, I'll just call it my own custom property source. And basically, you can say, okay, if somebody's asking for a property called name equals whatever, spring.data source or whatever, if it starts with this, you can then do something. You can say, okay, return blah. Okay, so you are able to override how this gets plugged in, this property source gets plugged in. There are some default ones, as you can see. We're able to read from the class path. We're able to read from file systems, etc. But if you want something more particular, it's not hard to override the default property sources in Spring. Okay, so good. Now the benefit of that is you can have a local development property for your local host, and you can have the properties from your vault, HashiCorp vault or something in production. Okay. Where are we, my friends? I think we've come a long way already. The code is looking a lot better. We are not managing this bean. We're just using annotations to discover it and manage it. We've looked at how to do dependency injection using bean provider methods. We looked at the fact that there's just bean definitions underneath the hood here. I think we're good. Let me close this. Let's delete some of this old code that we no longer need because our code is just being managed by Spring for us, right? What can we do to make this even better? Am I missing something that we should be talking about before we move on? No, I think we're okay. We're doing good so far. I am gonna put this down. All right. Oh yeah, commit. Yes, very good, very good. Thanks for the reminder. Okay. Git status. Oh, we deleted. There. Okay. Git status. Git commits. Oops. More Spring features like environment and okay. Git push. It says everything is committed. Very good. There you go. So we'll get rid of all this stuff now that I've committed it with it there. Okay, so we've got the code using the environment. We've got the properties. We've got the infrastructure code. We've only got a few infrastructure beans here. Basically, we've got our customer service, doing some work. We've got declarative transaction demarcation. And by the way, I put transactional on the class, which is basically the same behavior as what I had before. But if I wanted to override it, I could put it on individual methods, right? And that's fine too. If I wanted to override the default behavior, maybe I want read-only transactions for some methods, and I want to do write transactions for others, etc. Okay, moving on up the stack a little bit here, friends. I think it's time we think about Spring Boot here, right? Because as good as this has all been, it's still very low level, and I don't even want to think about what it would look like to start using a web framework right now. We'd have to manually start up Tomcat or Jetty or something, or we'd have to deploy to a servlet container, which would be a huge step backwards in terms of ease of use and cycle time. So I don't want to do any of that myself manually. I'd much rather just have something do that work for me. So I'm just trying to remember, is there anything else we have to look at before we can move on? I don't think we looked at AOP specifically, but aspect-oriented programming is everywhere in Spring. You don't really need to know about it or use it, but you should know that when I created that proxy, that's kind of an implementation of aspect-oriented programming. I'm not using the framework inside of Spring for aspect-oriented programming, but it's an implementation of the ideals of aspect-oriented programming, okay? Let's see here. Okay, I think it's time to go a step further. So I've got this application context. We looked at red string, we looked at refreshing, starting it. We've got a bean here, got a bean out of it. But this is kind of ugly because I have to write this code in the main method, right? Obviously, well, first of all, ignore that. This should be a test. That's obvious. That should be a test. But we're not going to get into testing just yet because I just want to keep it straight and center and easy to understand. Okay. But second of all, I have to do this work in the main method. And what I really want is a way to get access to the Spring application context. Yeah, okay, we can do logging, sure. I mean, it's easy enough. for AOP, right? That's a suggestion. I don't really know if we want to show too much AOP, but you're right. We could do that, and it's not hard, so maybe we'll do it just to get it out of the way. Okay, so we've got this application context. It's a good suggestion, by the way. I don't mean to dismiss it. I'm more dismissing AOP writ large because it's fundamental to how Spring works, and yet I'm not sure that you need to know about it. Like, it's gotten to the point where all the major use cases for which AOP serves are already sort of provided by the framework proper. And these days it's just, I don't know. Maybe I should. Okay, we'll think about it. Let's have a think. Okay, so I think I want to let's just do Spring Boot. Let's do that. So what we're going to do is I want this code, as much as clean as this is, it's still infrastructure, right? Same thing for all of this. In fact, all of this is infrastructure. Wouldn't it be nice if I didn't have to write this? This wasn't so bad. It wasn't hard. Like, I know that I need transaction management, so I did that. I know I want to do component scanning, so I added that. I know that I need to read these property files in, so I added that. I know all these things because I've been writing enterprise apps for decades, and I've been using Spring for decades, right? Literally both, decades, almost 2 decades with Spring, and more than 2 decades in software. So I know about these concerns, but they don't make it easy, right? Like, if you don't have an awareness of how all the stuff comes together and what you have to do to get to this, then maybe it's not going to be obvious to you. I don't know. I mean, it's been so long since I was like starting off in this world that I don't even remember what it feels like to be confused about this stuff anymore, right? And that's the point. That's the problem, my friends, is that this stuff, it makes sense. It's not that bad. It's 51 to 83, so 30 lines of code, 32. I mean, it's not scary to me, and it doesn't feel like a burden, and something needs to do it anyway, so it might as well be me. But that said, this is just data access. All we've done is build one bean that can read from a SQL database and have declarative transaction demarcation. This is hardly the base of like a scalable approach to building software. And we haven't even looked at other kinds of data access. We haven't looked at web programming. We haven't looked at integration and messaging. We haven't looked at a number of other sort of concerns that go beyond what we've done here. So what I would like is just to be able to delete that and then have the same result, right? I want to have the same result, but I need some help. And so this is where Spring Boot comes in. With Spring Boot, I get opinions about how to build applications that are reflective of people like me who have been on the Spring team and who have worked in the industry for a long time. So Spring Boot documentation. Obviously, the people that know Spring Boot, the very first few people, are a lot more intelligent than I am, but I'm in there, right? I was there when it was created. I was there before it was created. I was contributing to it in small ways here and there, and I have been for its entire life. Remember, we first announced Spring Boot back in 2013, right? So 0.04 or something like that. It wasn't even 1.0. 2014 was 1.0, right? So I love Spring Boot. And the reason I love Spring Boot is because it means that I am irrelevant, which is good. Trust me, you don't want me when you can just do it yourself and get there faster too, right? I will slow things down. I'm old, and you see me like slowly typing, and I don't know what I'm doing. I've forgotten so much stuff. And so it's much better just to have this automated, to have the expertise of the Spring team automated for you, right? You want to pair program with Phil Webb and Dr. Dave Sire, right? And Stefan Nicole and Spring security lead Rob Winch. And these are just some of the names. There's Michael. He was in the chat earlier. Hi, Michael. Right? Some of these names this is just a few of the names. These are just people that contributed to the documentation, but I was also in the code. And my point is, people like me are not what you want. You want automated support, right? And Spring Boot gives that to you. So what we're going to do is we're going to bring back Spring Boot. We're going to get rid of that. We're going to say Spring application.run boot 3 application.class, passing in the arguments. And you see, I got an application context. Run returns an application context. Everything else should be exactly the same. Okay, let's just run it and see what we get. Okay, what did I miss? Oh, there's a web server now. Let me disable that opinion. It's too smart. Let's get rid of some of the stuff that we don't need just yet. Whoops. I don't know why there's a web server stuck on my port, but for now, let's just get rid of it. Okay. Okay, what happened here now? Customer service, no bean. Oh, okay. So the other thing we need is we need to have the Spring Boot application annotation. This annotation also uses component scan, just like before. And it also uses add configuration, just like before. But it adds a new dimension called autoconfig. And we'll talk about that in a second. But let's just see if our code still works the way we thought it would. There you go. It does work. So there's our data on the console, just like before. But now we have these nice logs. And the logs are simple. We don't see all the debug stuff. And we got this nice, amazingly well done Spring Boot ASCII artwork. Okay, so we get that for free, and it's the same code, same exact behavior, basically the same runtime. Everything is the same, but we've now used Spring Boot to do most of the work for us. And I got to delete all of that configuration, the whole configuration class. I don't need anymore. The JDBC template, the data source, the transaction template, all the work around proxies, all that is just gone. I deleted all of it. And I get the exact same behavior because Spring Boot understands that we want those things anyway. And so it's pre-configured it for us. Okay. So you could write the code that I wrote, but why, right? And where's my cs.class? Yeah, here it is. cs.class is still a proxy, just like before, right? Everything else is the same. And it also, by convention, it reads in the property file called application.properties. So that property source that I created, oh, it turns out that's actually the default in Spring Boot. And so those properties that we provided, those are exactly the same ones that Spring Boot uses. Surprise, surprise. I'm sure none of you are surprised. But we're now using Spring Boot. And Spring Boot makes it so that we have opinions around how to build software in the enterprise using Java. Okay, lots of good opinions. Now, what about this mess, right? This is all like I don't really want to sit here in the main method, right? I want code that gets invoked after Spring has created all the other beans, and it gets a chance to run when the application is started up. And so for that, Spring has this type called application runner. So my application runner implements application runner. Implement these methods. And yeah, you can inject that customer service here. Private final customer service. And use that here. And now we don't have to do application context.get because we have customer service. We'll just add SLF for J. And we're going to call this CS, so everything else continues to work. And there you go. There's the exact same code. This will get run when the application starts up. Same as before. There's the data. And now we don't even need this variable here. Okay. Not bad. So let's make sure that we got all that cleaned up. Okay, but so this is actually what you get. When you create a brand new project on start.spring.io, you get this out of the box. And that's why, because it may look like very little, but it's doing so much for you. Okay, it's doing so much stuff for you. Now here, I'm creating a bean, and the only thing I care about is this side effect. I care about the application runner side effect, which is it gets invoked when the application starts and gets passed in the public static void main argument array. There's also another bean called command line runner, which gives you the argument array, the string args. If you just want arguments as strings, you can just inject them like that. They are functionally exactly the same. I think one gets invoked right before the other, but basically they get invoked at the same time. Okay. I happen to like application runner, doesn't matter. But nonetheless, I'm still creating this bean just for the side effect. I want the callback. I want the event listener, right? So instead of doing that, I like to create these as beans like this. So return event, and then do some work, and then that, okay? And in the runner, I'll pass in that there. Okay, paste, and return to SLF for J. Now we don't need this anymore. We don't need that whole class. All right. So now it's running. We've got our code. Everything seems fine. There's our data. It's getting invoked as usual, you know. Good stuff. Good stuff. So now we talked about events, right? We talked about events here. Events are a huge part of Spring, and they're supported in Spring framework, just like we saw earlier. But they're really powerful, I think. And so I like to use them in Spring Boot because they give me a natural way to create modular code bases where I communicate from one package to another, not using public methods, right? Public types. In general, you should try and avoid having public types. What you want are package private types. Notice that for everything that I don't have public, right? My customer service isn't public. My record isn't public. Public is your enemy. If you have public everywhere, try and delete them and see what happens, right? And if you have lots of compiler errors, that means your code is probably structured incorrectly. And the way to think about structuring your code is what I talk about all the time as interfaces and events, right? I use interfaces to read data. I use events to publish state changes as announcements to other parts of the code. And you can do that with Spring's application event publisher and event listener, or application listener interfaces. So let's talk about that, okay? Spring publishes an event that you can listen to. So I'm going to create a bean that implements this listener called application event. Okay, and you're going to listen for this event. So this event tells you that the application is ready and is able to start receiving traffic. And in fact, all this code go here because basically the application runner and all implementations of this bean, of this interface, all exist at the same time, right? Application runner, application event listener for application ready event, and command line runner all get run around basically at the same time. In fact, I think application runner is probably ultimately just an application listener, right? I couldn't be sure. It's been too long since I looked at the code, but you get the idea. So this is an event listener. I'm creating a bean that implements this interface, and I'm listening for this application event. Well, there's all sorts of other events. So let's go up here, Spring application event, application event. This is a core class that's been there in Spring since basically 1.0, right? And you know, here's the application event hierarchy. Look at all these different events that get published for you that you can use to tap into different lifecycle events related to the functioning of your Spring application, right? So what's a good example? Spring application, context started, context closed, bootstrap, application failed event, application prepared, whatever. You can even listen to events that get invoked when you run your Spring app inside of a unit test, like JUnit, right? Or whatever. So yeah, lots of like very interesting stuff here. Availability change event, all that. In order to really see some of these other events in practice, though, we need to start thinking about the web, okay? So what we're going to do is we're going to go back to our build. Well, first of all, I'm going to find out how to kill process on port, whatever. Okay, I always forget how to do this because it only happens like once a decade. Tomcat. Oh yeah, it's Tomcat. Okay. Kill or okay. When in doubt, use violence. Kill -9. ls -t -I. Don't use violence, by the way. That was just a joke. Let's see here. So do I not have something on port 8080? Let's just try it out. I don't know. We go here and we're going to go to build.gradle and we'll say bring in the Spring Boot web support. Oh, that's the other thing that we've got here is to kill I can use kill to kill a process, but I'm looking for a process on a particular port, right? So that's what I was, but maybe I don't need it anymore. Let's try. This is the other thing that Spring Boot gives you is you get these nice starter dependencies. Most of the time when you see a Spring Boot starter, these starters don't actually have any code in them, right? That's the important thing to understand. They only do dependency management. They bring in other dependencies. Those dependencies have code. But our starters are usually just empty pom.xmls in a jar that serve to keep all the different dependencies level set. This is another one of the big things that Spring Boot gives you, that Spring Framework and other technologies just don't, right? These starters have Yeah, just kill. Oh, use the just kill. Okay. Yeah. I love that. Yeah, you can, these starters bring in dependencies for you. So I don't have to worry about bringing in Tomcat and the servlet framework and all this other stuff, right? It just gets done for me automatically. Let's go ahead and restart this. Maybe it'll work. I don't know. Hey, it worked. Good. I don't know why it worked. Is it on the... Yeah, there you go, Tomcat. So I brought in Spring Boot Starter Web. It set up an embedded Tomcat. It set up, it listens on the port. It set up the servlet framework. It set up Spring MVC, set up all the useful filters for me. All that gets done automatically out of the box, and I don't have to worry about it. So let's create another listener here. And I'll say application listener, embedded container, whatever. Let me see, embedded server. Nope. Let's see, what's the application event that we want? Application ready event. Application event. Application, I want the... Here we go. Exit code, job execution, RSocket, reactive web server, server initialized. Servlet web initializer, servlet web server initialized event, or web server initialized event. This is the parent of these two. Actually, probably of all three, but at least those two. So let's see. Yeah, this is to tell you that your web server is ready. So I can listen for that event, right? Let's see here. Good. Application listener. There's the contract. And I can say, okay, let's log the fact the web server is ready to serve HTTP traffic. Okay, on port, whatever. And we can say event.get web server.get port. Now you've got a pointer to the port. Okay, and again, this is an application listener that implements that event. Let's just replace it with Lambda. Why not? And restart. So there's our thing right here. Web server is ready to serve traffic on port 880. And you can see it actually happens right before the actual log message from Spring Boot itself. So this is a little redundant, but you can also guess what's happening here. This log is probably just an application listener listening for that event. What about if you bring in, like, let's say the actuator? The actuator, we're going to talk about that in a little bit, but the actuator, or well, not today, probably next stream or one of the ones after that. The actuator is a set of management endpoints, right? And these endpoints give you information about the surface area of your application. Well, what if my application is now healthy and is able to respond to traffic? Well, I can listen to the availability change event, create a new application listener for that. And I'll say, okay, great, log the service is healthy. And then we say, event.get state to string, right? I'm going to log that out. It's Lambda. So, correct. So the service is healthy at the moment, okay? So I can see when the service is able to start responding to traffic. I can also respond to when the service is sick. If something goes wrong, this will get called again, and I'll get a chance to respond to that. Okay, so this gives me the ability. These events give me the ability to respond to change in the application, and you can also use them to broadcast information to other parts of the application that need to care about that. So, for example, whenever we write a new record to the database, I think we should publish an event, right? Okay, so let's do that. So we're going to create a new event here. Class customer created event. Okay, extends application event. Okay, inject this. I'm going to say that the type that we care about, the source, is a customer, and we're going to override the method from that object so that it returns the downcast version of that data. Okay, throw in a little event here, and we'll say broadcasts availability of a new customer, code customer in the SQL DB. Okay. Okay, so now let's publish an event whenever this customer service creates a new event. So I'm going to inject a application event publisher. So in the constructor, so we'll say application event publisher. This.publisher equals publisher. Now, when we get to this last point, our customer, say this.publisher.publish event, new customer created event, passing in this customer like that, return customer. Now, whenever there's a new record in the database, we can get a notification about it. Okay, so let's say we want to create a new HTTP controller that keeps track of all the customers. I don't know, maybe you only have a few thousand customers, who knows, right? Or even a few million you could store in memory and not be in a lot of trouble. So let's say class customer HTTP controller. I'm going to create a web controller. I'm going to get into web programming in a little bit here, but at controller, and I'll say at response body, and I'm going to have an endpoint here called customers. I'm going to return a collection of customer. Well, where does this data come from? I could query the database every single time, but that's going to be slow. Instead of doing that, I'll have application listener, customer created event, right? All I'm doing is returning all the records. Then I don't really need to, private final, let's see, private final set customer. Okay, customer set equals new concurrent skip list set. So as long as the reads are a lot more than the writes, then this will be just fine. I need to provide a comparator though. So comparator dot comparing new function of customer returning an object of integer, right? The primary key. I'll say return customer dot ID. And I can just return that like this. Method reference, voila. So there's my customer set. I'll just call it my customers. You can even call it like customers cache or something like that, right? Whatever you want. But I'm gonna, whenever there's a new record, okay, I'll return that from there. But whenever there's a new record, I'm gonna modify that customer cache, adding the customer. Okay. So now this endpoint, and maybe only this one, maybe most of the other ones need a query, but if you're just returning all the data, that can be lightning fast. You're just storing a copy of the data by listening for this event. Okay, so now, okay, it's up and running. Localhost 8080 customers. There we go. I didn't have to make a SQL query. I didn't have to waste extra resources. So each time it published an event, I got that event and I was able to respond to it. And you can do all sorts of things with event listeners, right? You can create a system that is more responsive to change elsewhere in the code base. And the nice thing about this is I'm using events to communicate not just with my own modules, but also with other parts of the system. Well, of course, this brings us to what I was talking about earlier, which is you should be designing by feature, not by role. So here, I'm going to go ahead and create a new package, and I'll just call them customers, okay? And I'll put customers, yeah, continue. I'll put customer created event in the package, refactor, continue. I'll create customer HTTP controller. I'll put that in the customer package, continue. And customer service, I'm putting that in the package, and I'll continue. So here, all I care about is doing something with the, well, in this case, I don't really need, I want this application listener to live in the package where it belongs as opposed to other places. So I'll create a listener here. If the system got abruptly terminated, then application events might be lost. You're 100% right. Yeah, so you might want to have something where you reload all the data on startup, and then from there, if it's still running, it'll get all the events, right? That kind of thing. Because the data's still been written. You've already written it to the database by that point, right? So it's not like it's lost. You're just now, whenever somebody wants to read all the data, you're communicating that those records have been updated, by events. So I'm going to create a customer initializing listener or something, whatever. Okay, so here we go. Customer initialization configuration. I don't know, whatever. This is a pretty silly thing that you wouldn't even have in a proper application. Okay. So there we go. My original code is still there. This is now unburdened by all that extra stuff. My main code doesn't know about my customer service. I might want other parts of the system to know about new customers being created. Okay. So now I can go over here and I can say, okay, new orders package, that kind of thing. And I might have, whatever, order service. I don't know, just some simple example. In which case, I want this thing maybe to know about the fact that I've got a customer created, right? Maybe I keep a cache of all the customers, just like I see up there. So I'm going to now, this you can make public. I wouldn't mind making events and domain types public, but services, things like that, controllers, all that should be packaged private. The only thing you're communicating from one package to another are your events and the payloads required to support those events. So now I've got this order service that's running in another package, at service. Okay, voila. And here, same idea. I might have some thing where I need to care about the fact that there's a new event. Maybe I might have I might recalibrate myself. I might do something to query the database. I might do whatever. But the point is, I'm using commands and I'm using queries to keep my system in check. But I'm not explicitly injecting other things unless I absolutely need to. You want to reduce as many cross-package dependencies as possible, right? And if you have something that must be shared, then ideally that package, that interface, for example, if I extracted this out to an interface, that could live in the root package down here in boot 3, right? So it becomes very natural to create modular systems that follow the best practices of CQRS and things like that. Okay, friends, I think I don't know, what did we learn today? We learned a lot. Hopefully we learned a lot. I don't know about you, but I feel like we covered a lot. And I think, so I don't know where we're going to go tomorrow. Maybe we talk about web programming writ large a little bit. We talk about that. Or maybe we actually talk about data. Actually, we could talk about data tomorrow. No, we're not done. Now I remember one more thing. I forgot. We're talking about events. Events are great. Love events. I forgot one thing. We forgot to unpack the secret of what is making Spring Boot, right? Which is that fourth dimension. Remember, I kept on saying we've got these 3 things: portable service abstractions, dependency injection, and AOP. Those are all Spring framework. What is Spring Boot? What's the magic of Spring Boot? In order to understand that, you need auto configuration, right? And auto configuration is, I think, if you look at the old documentation for Spring, this documentation from decades ago, right? The Spring Triangle documentation, Spring framework. Let's see. Core technology, Spring Boot. Where did it go? We used to have this amazing in the training that we did decades ago, and I'm sure it's still being used now, but in the training that we had decades ago, we talked about the Spring. There we go. This one. This picture is decades old, like super old. And the core of it is we have dependency injection, AOP, and portable service abstractions. Those are the core of Spring Framework, right? Those 3 things make Spring Framework so powerful. But as we saw, having full control over your code base, though powerful, can be a little overwhelming. And so, let me see, let's visit this page. This is the old Spring Python project, and they preserved a picture of the triangle here, right? Which is cool. This triangle is actually from Spring itself, right? I think this is just a reprint of it. But this is the core triangle, and the missing piece to get rid of some of the verbosity, as you've seen so far, is auto configuration. And that auto configuration is what's actually doing all the work for us. Remember, I got rid of all the transaction demarcation. I got rid of the transaction template. I got rid of everything. And then we added even more. We just added dependencies on the class path. And suddenly, ta-da, magically, new stuff was being done for me always. Well, there was a Spring Python. I'm not sure that it's all that maintained. You know that Spring, we've had Spring variants for, let me see, there's Python. There's a Ceylon. There was one for Ceylon. There was Cold Fusion. There's .NET. There's a few others. I've forgotten Spring variants, right? People have the .NET one we actually created, right? That's actually a project that Spring.NET. Yeah, there you go. This one. So there were a lot of different versions of Spring, but right now, if I were starting today, the only one I would use is on the JVM, right? Yeah, this is 2012. You can see the last announcement from Spring.NET. What is all this? Git branch main plane. Ahmed, you're amazing. Can you send a pull request? Is that possible? Can you send? That's still cool. So Ahmed looks like he's been doing work to make it easier. Well, yeah, the Spring.NET again. This is 2012. It's been more than a decade since the last release, so I wouldn't use this today, right? It's no longer in vogue, but it kind of lives on, sort of, in Steel Toe, right? This project, create .NET microservices. This is kind of like Spring Boot, sort of, for .NET. Not Spring Boot the whole thing, but more like certain parts of Spring Cloud in an easy to consume .NET package, right? So you get like Actuator, you get Eureka and the config server and a few other things, right? It's event driven, it's popular, 44 million times. Ooh, yeah, so people are using it. Steel Toe initializer. Look at that. Does that look familiar? So you got this. You can, you've got Spring Cloud config, configuration values, random value configuration, MongoDB, MySQL, OAuth connectors, RabbitMQ, Redis. Why would you do that? You got all this stuff, right? All this stuff is here for you. Cloud Foundry. So, Spring.NET is dead, but Steel Toe endures, and it's awesome. And you can see this. Remember what I told you about yesterday? This start.spring.io is open source, right? So you can create your own start.spring.io. Okay, that's a good little digression. Okay, let's talk about this auto configuration, my friends. Ahmed, buddy, how can I look at the code? Can you send me a message on Twitter? My direct messages are open. I'm at StarbucksFan or something. Send me a Git repository where I can look at the code, and then we can have a pull request. I just want to look at what's happening there. I'm at StarbucksFan on the Twitter. So my direct message, by the way, everybody, my direct messages are open. It takes me a while to respond sometimes, but I do keep them open for a reason. I'm happy to try to help. Okay. Let's talk about autoconfig. Autoconfig is the secret sauce. So the reason I mentioned all this stuff, the reason I talk about this triangle is because this has been here for decades. And in 2015, I don't know if you know this, but Spring Framework was created. The first person to work on it was a gentleman named Rod Johnson, who's a lovely human being. And he left the Spring team in 2012, after a few years after VMware bought SpringSource. So they brought the company that he had created that created Spring. And again, he's the father of Spring. He's the original first person to ever write code that went into Spring. Nowadays, you've got Jürgen Huller, who's just another lovely, amazing human being. And Jürgen is the lead of Spring Framework, and he has been for more than a decade. So there's probably, if I had to say which person has done the single most to take Spring forward into the future, it's obviously going to be Jürgen, right? Because Jürgen is still here working day in, day out. Whereas Rod left more than 11, he left 11 years ago, right? Like long time ago. And Spring has been, he created Spring in like 2001. And it's now 2023. So you can kind of see it's been 22 years of Spring, and Jürgen has been there for most of that, right? So Jürgen is a lovely, lovely person, but Rod is the first person who worked on it, and he left in 2012. So he left before we created Spring Boot, right? So we created Spring Boot in 2013, and Rod's a friend, so I kept on telling Rod, hey, bud, you got to let me show you what we're working on. It's amazing. You've got to come see what we're doing. This stuff is not like what you remember. The Spring Boot stuff, trust me, I know you have ideas about what it should have looked like and what we had hoped it would look like back when you left, but it has come a long way. And I kept on trying to tell him, hey, you've got to let me show you. And eventually, because we used to, we get together and whatever, but I haven't seen him in a few. I haven't seen him since before the pandemic, though. The pandemic froze. He lives in two different parts of the planet. But anyway, I haven't seen him, but we used to get together and we'd have we'd just hang out, right? But I kept on saying, you've got to let me show you some technical stuff, like talk shop, And I finally got to show him what it was, and he loved it. And then, of course, he did, right? Spring Boot, it's awesome. And he loved it so much, he started asking questions, and eventually he said, hey, this Spring 1, 2015, you think you can get me a ticket? It's like, yeah, of course, right? You're Rod, right? The creator of Spring. Don't worry, we'll get you a ticket. So, but I did ask him if he wouldn't mind coming and presenting just a little bit, just to speak a few minutes on stage when I was giving my presentation with Dr. Dave Sire, introducing Spring Cloud. And that presentation was, I'll never forget. I got goosebumps right now, because here's the father of Spring, right? Rod Johnson on stage with one of the fathers of Spring Boot, Dr. Dave Sire, right? And Rod, he left in 2012, but because of some weird circumstances, he broke his collarbone in 2011, and then he left in 2012 before Spring 1. So the last time he was at a Spring 1 event was in 2010. So here we are, 2015. It's been 5 years since half a decade since he was at a Spring 1 event. And this is the first time he's come back, and the first time he's been at the conference with Spring Boot out in the world. And so I said, would you mind like coming on stage and talking to people about it, and just say a few words about your thoughts on it and all that stuff, just so people could see. And we didn't tell anyone. We told nobody. He wasn't in the keynote. He could have been if he wanted to, but he was just happy to show up and be in the audience and all that. And we didn't tell anybody. And it was on the slide, it just said Dr. Dave Sire and Josh Long, right? And then we introduced why we blah blah blah. Spring Boot's great. Here, my name's Josh. That's the good Dr. Sire. Yeah. And then what people may not have realized is that on the floor, in the back, in the chairs, in the room, everywhere, there were Spring team members, right, sitting there on the floor, because they knew that I had gotten Rod to come back to say a few words, but nobody else in the audience did. And the Spring team has already seen my presentations. That whether they like it or not, they've already seen it. So most of them don't bother to come take chairs in a crowded room when they know there's other people that want to see it, right? But this time they were coming, and they came and they sat on the floor, and they were standing on the walls, and it was crazy. So then I said, look, and now a person who needs no introduction, Dr. Rod Johnson. And Rod came on stage, and like the whole room, erupted in applause, because he's the creator of Spring, right? And he came up on stage, and I'll never forget. He talked about it like this. He said, we created dependency injection, portable service abstractions, and ALP. But the new innovation, the thing that we've done, the new thing that Spring Boot brings to the table is this auto configuration. And so realistically, if we had to do it over again, I guess they would have done it as a square, right? Dependency injection, ALP, and portable service abstractions, and auto configuration. And so that's the missing piece here, friends, is this auto configuration. It's so important. And the reason it's important is because it allows me to delete all the code that I deleted earlier and still get more. And the way it works is pretty trivial. If you know what a service loader is, then, oh yeah, Dan was there, he says. That's cool. Like I can't even believe I was there. It was ridiculous. It's one of my all-time favorite memories in the world. The way this works is it used to work in Spring Boot 2.x and below. We had this mechanism called spring.factories, and it's like a service loader. So you'd have an attribute that said org spring framework boot auto configuration enable auto configuration equals, and then you'd have a comma delimited list of classes. Now you've got auto configuration.imports. Okay, and this is the new thing in Spring Boot 3.0. And you can see we've got this jar Spring Boot auto configure, and it's just it's not a comma delimited, it's just line breaks of classes that get loaded by the application by Spring when it starts up, and it tries to create and run all of these. And you can see there's a lot. There's 142 auto configurations, and they do everything. There's Cassandra, there's Couchbase, there's JDBC and security and MongoDB and GraphQL and security and Prometheus and InfluxDB, JSON marshalling. You've got distributed transactions. You've got Jersey for JAX-RS and Spring MVC and the reactive web stack and Java Mail and Kafka and LDAP and Liquibase and forever, right? And this gets a little overwhelming. And so we obviously don't want Tomcat, Jetty, Netty, and Undertow all running at the same time, for example. That would be terrible. So if you look at some of these auto configs, you realize, okay, it's not as bad as you think. Here's the auto configuration for RabbitMQ, okay? And you can see I apologize to those of you who are colorblind, but this is red, okay? It's red right here. So the IDE is telling me that these types don't exist. They're not on the class path. And that should be a clue. It's a cue to Spring that we shouldn't bother to do anything with RabbitMQ unless these types are here. If they're not here, then this is going to fail. There's nothing we can do usefully anyway. So the very first thing you'll often see after @configuration or auto configuration nowadays, this doesn't actually do anything special at the moment, but hopefully in the future it will. We're hoping to automatically generate this based on this in Spring Boot 3.0, but lack of time and deadlines and all that stuff. So we got rid of that. But so right now, this is just a meta annotation for @configuration with proxy bean methods equals false. Okay. Okay. But after you have the configuration or meta or @auto configuration, you have conditional on class, and this is saying that Spring is going to try and load this configuration class, but it's only going to load it if this type and this type are on the class path, right? And don't worry, it's not doing class.forName. Well, first of all, remember these annotations don't get loaded; they're not validated by the compiler, right? So, so this doesn't cause any issues. But we have a processor that looks at this annotation and then uses not CGLib, maybe it's CGLib, no, ASM. I think we're doing ASM, and we look for whether this type is on the class path, right? That is what allows us to know if we should bother loading this configuration class. If this type is not there, then there's no point in doing anything in here because it's all going to blow up. It's all going to throw class not found or no class def errors, right? Class not found exceptions or no class def errors. So if they're there, okay, great. What else do we have? Well, then we have import. We import some other configurations, and we have nested configuration classes. And these nested configuration classes have conditions. They say, okay, this is a bean. It returns a bean of this type, but we only want to return a bean of this type if the Spring user, if the developer, if you and me, haven't already defined a bean of that type, right? Same thing for caching connection factory configure. Same thing for all this stuff. If you've already defined a bean of type connection factory, then there's no need for you to define another. There's no need for Spring Boot to provide a connection factory, right? Spring Boot's already going to do that for you, but only if you don't want to do it yourself. So if you have a bean of type connection factory, Spring Boot will back off, right? So we're delegating to you to do whatever you want to do. But if you don't do something, then we have strong opinions about how to do it ourselves, and we can do it for you automatically, right? That's the magic of Spring Boot, is that you have full control. You can override every single part of the machine if you want by overriding the beans and by using these cues like the presence or lack of types, lack of presence for certain types in the class path, and the bean, the definitions of beans or not. That's a cue. These are cues that tell Spring Boot what you want to do. Okay, you don't even have to write code. You just add things to the class path, and that automatically gets you certain default behaviors. Okay, and that's why we have these starters. these starters are sort of, in a way, the API. That's how you tell Spring Boot that you want certain things done for you. Just add the types to the class path, and that'll automatically light up some of this auto configuration. The auto configuration will come to life with those types present in the class path. Okay. Let's see here. There are some properties. Remember earlier we looked at those property files? Application.properties. Spring.datasource.url, spring.datasource.password, spring.datasource.username. These are properties that Spring cares about. And I can actually use RabbitMQ properties too. I can say rabbit host equals my RMQ. Okay. This is a property. If I command click on it though, you'll see that that property actually comes from this object called rabbit properties. And this property is just a Spring bean. It's annotated with @configuration properties. And we're telling it that all properties that are prefixed with spring.rabbitmq should be mapped to this rabbit properties object. Okay. And this is where we're telling Spring to do the magic trick of mapping properties in the environment to the fields on this Java object, this rabbit properties. We're saying enable configuration properties, rabbit properties. We can then inject it, just another bean that we can inject into the into our beans, and we can then dereference properties. We can say, I want to get the port, I want to get the username, and you can see there's fields on that. So if I where's my code here? Okay, if I go here, in theory, if that configuration class for RabbitMQ existed, I could create a bean. Ready. Me either. Okay, rabbit listener. I could inject that here as well. Properties, right? Event log.info properties dot get host, right? If the config file, if that configuration worked, if that configuration class evaluated to true because these types were on the class path, then this host value, get host, would be equivalent to what I specified here. It would be my RMQ, right? So that's the other part. There's auto configuration and those properties that get provided, and they work together to package up stuff in a way that you don't have to worry about it, right? It just works for you on the class path automatically. There you go. That's the final part of the equation there. Now you understand the foundational level of what Spring is doing. And remember, if you understand all the stuff we looked at yesterday and all the stuff we looked at today, configuration, dependency injection, AOP, portable service abstractions, properties, all that kind of stuff, then now you understand how to understand this. Now you know how to do and work with this kind of stuff, right? You can understand what auto configuration is. And the best part about auto configuration is you can package it up, put it in your own jar, create your own text file called autoconfiguration.imports, right? Autoconfiguration.imports, and that can go in this meta-inf directory, right? So it's a meta-inf spring aot.factories and org spring framework boot autoconfiguration.imports. As long as you have the same exact directory structure and you put your autoconfig class in there in your jar, as long as you do that, somebody else can add that jar to the class path, and they also will have auto configuration. They'll be able to use your auto configuration for whatever you want. So if you're a large organization with lots of services in production, but you have a certain framework or a certain auditing technology or a certain way to do security or whatever, just put it in auto config, distribute that, and then everybody in your organization can reuse that to build systems and services in a more consistent and scalable fashion. Okay. There, I'm so glad. We almost ended the stream without talking about that. That would have been a crime. That was on my list. I even had that in my notes. I'm so glad I didn't end it before I remembered that. That was the whole point. I wanted to lead to this auto configuration today. All right, my friends, we did good. Well, not great. You did great. Me, I'll give myself a 5 out of 100. But tomorrow it's gonna be better. You just watch. Maybe even later today. Who knows? I never know what I'll get up to. But I might get the itch and want to do some more streaming today. But as always, if you miss an episode or if you miss an installment, as always, join me here on the YouTubes, right? It's an okay place to be. It's not great. You can make a lot of mistakes that are a lot worse than subscribing to this channel. I mean, as far as I know, nobody has died from subscribing. Do I actually end my stream? Yeah. I mean, in my head, they're streaming 24/7, but because I love my audience, I do them a favor and I just stop. All right, everybody. This was fun. I hope you all got something out of this. Yeah. Is that it? That's good. Feels good. Have a good one, everybody. Talk to you later.